Good evening. Today is Friday, December the 4th. Today in geometry, we looked at the other two sets of concurrent lines that occur in a triangle, these being the medians and the altitudes. So I'll share my screen and show you how we work with those. We will first draw us a triangle here. Triangle. The triangle doesn't have to be any special type of triangle. Okay, so we can say this is triangle ABC. Now, when you do the medians, the first thing we will look at here is what's called the medians of the triangle. And the medians connect the vertices with the midpoint of the opposite side. Okay, and the point they create, once again, it's a concentric point or concurrent point, and it's called the centroid. And I'll come back to that in just a second. So once we get here, we are drawing the line that comes from the vertex to the midpoint of the side. So we look, okay, that looks to be about the midpoint there. If we come from this vertex, we come down to, now if you're working with a graph or something, you can take a ruler and measure this, but there would be that midpoint, and then we would have this line. Now, since I've got those two, this one would come across and come about right there. Now, so what you see here, so if we come back and we have, so let's say this is D, and this is E, and this is F. Now we call the point here, the concurrent point, we'll call this the centroid. Now here's the interesting thing about the medians. When you draw the medians here, the long point of each one of these medians, like if, for instance, if this right here is 6, and it's 6 from A to P, then from P to D is half of that. So this would be 3. If this one right here were 4, see, then that's the long part of this from C to P. So from P to F would be half of that, which is 2. And if we come across here, let's say this one looks to be about like 5 maybe. So if this is 5, then EP would be 2.5. So when you have a problem that tells you the concurrent point is a centroid, then the key thing is you know this relationship exists. The long part of each one of these segments, the long part is twice the short part. So this is 6, this is 3. The long part here, twice the short part, and the long part here is twice the short part. So when you look at your homework problems, you will see that they will give you something like this. Now, they might not tell you it's the centroid, but if you look at your picture and you come in here and you got something like this, see if you got these 2 marks here and these 2 marks here, that tells you that D is the midpoint of side CB. And they'll come in here and they put a mark here and a mark here, and then they put 3 over here, 3 here, like this, and 3 here. So they don't have to tell you that P is the centroid, because you know it's the centroid because each one of these segments is a median going from the vertex of the triangle to the midpoint of the opposite side, okay? So that's the third set. Now, if you look on page 377, if I'm not mistaken, in your book, there's a table there that covers, remember, the circumcenter is created by the perpendicular bisectors of the sides. The incenter is created by the angle bisectors. And here we have the centroid, which is created using the midpoints. Now, the one final thing we have, I'll go ahead and erase this. So if you need a second, pause your video and then you can look and see. I'll go ahead and erase this and we'll look at the final set of concurrent lines that exist in a triangle. And these are what are called the altitudes. So we get rid of this. So now the altitude goes from the vertex perpendicular to the opposite side. Okay, and now the interesting thing, while the centroid will always be inside of the triangle, the altitudes, especially if you have, I'll draw you a obtuse triangle here, like this. So if you have an obtuse triangle, then the altitudes will not be inside of the triangle. For instance, see, if I take, okay, this will be A, this will be B, and this will be C. So if I draw the altitude from C here, perpendicular to the opposite side, it goes about like that. That looks to be perpendicular. So that would be point D. Now, but notice here that if I draw an altitude from A here, and I go perpendicular to the opposite side, I can't go perpendicular to the opposite side and be inside the triangle, right? So what I've got here is, if I look at the extension of side BC here, if we kind of go straight off like this, and we go like this, so the altitude is perpendicular to the line or the extension of the line, which contains the side. Now in this case, so if you have an obtuse triangle, two of the altitudes will always be outside of the triangle. So here, for instance, here's the altitude that goes from vertex B perpendicular to AE, so it's going to look about like this, and we extend the side like this, so you can see that there's the altitude there, the altitude here. Now the interesting thing about it, once again, see, if we look, if we extend each one of these altitudes, so if we extend it like this, back down in this direction, that looks to be about straight. And then I come down in here, and I come from here to there. And then if I do this thing correctly, see, if I come from here down to there, see, this one looks to be a little bit off. But these three altitudes will intersect at a concurrent point here. And that point is called the orthocenter. The orthocenter. Okay, so the orthocenter is created by the altitudes of a triangle. Now, there's nothing special about the location of the orthocenter here, in this case here, but like there is with the centroid. But you just need to remember that the orthocenter is created by the altitudes of the triangle. So once again, that's pretty much what we covered today. I'll go ahead and stop sharing here. If you look at your homework assignment, if you have questions, once again, send me an email. Let me know which question you're having trouble with, and I will get back to you on it. Otherwise, I'll see you Monday. Now, I'm going to pass out the study guides for the final exam on Monday. So I will post the study guides, or the best thing probably will be to just post the study guide as an attachment to a email to each one of you. So I'll try to do that sometime over the weekend before Monday. Once again, if you have any questions, send me an email. Otherwise, I hope you're feeling better, and I'll be back with you on Monday.